Question 21, we're given this parallelogram ABCD. We're given some extra information about it, which we can see on there. So AC is 8 centimetres, DC is 12 centimetres, angle DAC is 95. And it's always just worth checking we can see that we've got that information on the diagram as well. We need to calculate the area of the parallelogram. Now to do that, we need to recognise that we've got two congruent triangles here. So ABC and ACD are congruent. We just need to recognise that and use that because that means we can work out the area of one of the triangles and double it. We don't need to prove it in this question. But if you're not sure why they're congruent, I will just look at that quickly. We can see they share this side here. So through our congruence rules, we know they've got a shared side. We can see, so I lost where my pen was there. This angle and this angle are equal because we've got parallel lines across the top and the base. And we also know with parallelograms, opposite sides are equal lengths. So this side and this side are equal. So that's how we know they're congruent, but we didn't have to prove it for this question. So we're going to work out the area of one triangle and double it. They're not right-angled triangles, so we're going to need to use our sine rule for area. Remember, area is half of AB sine C. And what this means is A and B are two of the sides. And the angle we're looking at here is the angle between them. So we know the length of this side. We know the length of this side. What we need to find out to use this is what this angle is here. With the information we've got, it's going to take us a couple of steps to get to this point. First, we're going to need to use the sine rule, which remember where we know pairs of opposite angles and sides. So we've got this angle we're going to try and find out first. So we know the sine of that angle ADC divided by the length of the side opposite is equal to the sine of this angle divided by the length of the side opposite. Rearranging that, multiplying both sides by 8, we get the sine of the angle that we want But to find the angle itself, remember we need to use our inverse function. And we can just do that all in one step on the calculator like that. And that will give us the angle of 41.61. I'm not going to round it yet. I'm going to use that full value in my calculator still and just round at the very last step. So just a reminder, what we found there is the size of this angle here. And we've done that because we know the angles inside a triangle add up to 180 degrees. So we can find out this angle here. So the angle ACD is 180, take away the two angles which we know. And again, I'm not rounding that yet. I'm going to use the full value in my calculator. So now we've got the length of two sides. We know the angle between them. We can use our sine rule for area. So the area of one of the triangles is half times 8 times 12. Doesn't matter which way around we put those. Times the sine of that answer we just put in. And that comes out to this answer. Again, not rounding it yet. And we've got to double this because we've got those two congruent triangles. And now we're at that final step, we can round it. And it's three significant figures we need to round it to. So there's our third significant figure, so it's going to be 65.9 centimetres squared to 3 significant figures.